Hey everyone, welcome to the Neo4j live stream. My name is Will from the Neo4j Developer Relations team, and we are joined today by Daryl Ward from Neo4j Engineering. Welcome, Daryl.
Thanks for having me.
So you have been working on the Neo4j GraphQL library for a little bit, which is what we want to talk about today. And I guess specifically, we're going to be talking about the 2.0 release of the Neo4j GraphQL library. So you wrote a blog post that was just published today. The 2.0 release went out just today, so we'll definitely be getting into that. But I guess maybe at a higher level, before we start talking about what's new in the 2.0 release, maybe you could just give us like a high level overview of what is the Neo4j GraphQL library and why would I be interested in using it?
Yeah, sure. So the Neo4j GraphQL library, it's a library which basically takes your GraphQL type definitions and does all of the translation and things it needs to do in order to translate to Cypher, which can insert data and manipulate data in a Neo4j database. So it's essentially like a GraphQL to Neo4j translation layer, pretty much, as you can see from that diagram there. So it kind of sits in the middle of a GraphQL client and a Neo4j database. We released version 1 back in April now, I believe it was, and that was kind of good support for node types and a full kind of CRUD API and lots of good customization options. But it was missing a couple of features. One of them being relationship properties, which was really kind of the thing that we were really setting out to achieve with the version 2 release, which we did today. But this release also includes things such as cursor-based pagination. We've started adding aggregation queries in the form of a count query in this release. And generally, we've just taken the opportunity to kind of learn from the past few months of people using the library, improved a few different areas. And we're really happy with today's release.
Gotcha. Great. Well, I dropped a link to this page in the chat, which is kind of like the landing page for learning more about the library. And then I'll also drop a link to the chat from this blog post that Daryl wrote, which is specifically talking about what's new in the 2.0 release. And also drop a link to the documentation, which we're going to be looking at a little bit today. As we go through things. Cool. So for today, I think what would be fun is maybe to build a GraphQL API from scratch, backed by Neo4j, for a specific use case, a specific example, to showcase how we can, first of all, use the Neo4j GraphQL library, how we can use it with Neo4j Aura, and then also touch on these new features in the 2.0 release, specifically things like cursor-based pagination and relationship properties that that Daryl mentioned. How does that sound, Daryl? Sound like a good idea?
Yeah, sounds like a great idea. Let's do it.
Cool. So the first thing we need is our Neo4j database, and we said we want to use Neo4j Aura for this. So if you're not familiar with Aura, Neo4j Aura is Neo4j's managed database as a service. So I'll drop a link in the chat to the Aura page. So with Aura, we can provision and scale Neo4j instances in the cloud and not have to worry about managing Neo4j upgrades, backups, all that kind of stuff. And one thing that I really like is there is a free tier of Aura. So we can spin up an instance in the cloud without having to put in a credit card. And unlike Neo4j Sandbox, which is just like a trial, the sandbox instances go away after a few days. The Aura free instances stick around forever. So let's start off by provisioning an Aura free tier instance. We need a database name. What sort of API application should we build?
Well, we could do a few things, but I think maybe like a shop kind of ordering application, something like that would work well for this example.
Yeah, like an online store kind of thing.
Yeah, something like that.
Let's call it the GraphQL store. You can pick our region. I'm going to pick one that's closest to me. And yep, want the free tier. So the first thing, it tells us our password, which we will need to access our database. So I'm going to save that somewhere and say, yep, I have saved that. It also tells us our username. The default username is Neo4j. Okay, so that's going to provision our Aura instance. While we're waiting for that, let's jump over to the Arrows app. So this is, and I'll drop a link to this in the chat as well. This is arrows.app. So Arrows, if you haven't used Arrows before, this is a really handy graph drawing tool. So I like to use this as the starting point often for any project that I'm doing with Neo4j where I need to think about what the graph model should look like. So Arrows gives us the tools for doing that, for drawing our model, describing what the data model is going to be, defining our property graph, and then we can share it, export it into a few different formats. So let's start there. And so Gerald, you said we want to do a shop. So I guess maybe start with users.
Sure. Yeah, sounds like a good starting point.
So we'll have user nodes, and they have what, maybe like a username. That's a string.
Yeah.
We'll just start there and keep it fairly simple. We can change the theme. Actually, let's see if I can zoom in a little bit. Yeah, hopefully that's big enough. We can change the theme in Arrows, which is quite nice. I like to use the Bloom theme, which is the styling that you see in Neo4j Bloom, but you can also use browser, so it looks like the Neo4j browser theme. So there we go. Okay, so we've got users, and users are gonna place orders.
Yeah, so sounds good as well.
So we'll create an order node. Let's make that different color. And for the properties on order,
Probably gonna have like a order number.
Like an order ID.
Order, yeah, ID, yeah, sure.
And maybe like the date it was created.
Yeah.
So kind of the general process, I guess, that I think of when I'm going through this modeling exercise is to first identify what are the entities, those become the nodes, how are they connected, those become relationships, and then what are the attributes, what describe the nodes, those become properties. And then I kind of think, well, can I traverse the graph to answer the questions that I have? If I can think of a traversal through the graph that answers my questions, that addresses my business requirements, then my model is good. If not, then I need to iterate. So maybe at this point, it'd be good to talk about what are the requirements of our application going to be. So far, we know that we have users, that we want them to be able to place orders. So let's name this relationship here, maybe user placed an order. But we also need some products in our order.
Yeah, absolutely.
So let's have this be kind of a simple store where we have maybe two kinds of products. We have books, and we have maybe videos.
Sounds like my kind of store.
Oh, and let's make these different colors as well, so we can tell those are different node labels. Okay, so a user can place an order, and that order will contain, let's say, contains videos. or contains books. And then for book, a book is going to have what, like a title?
Yeah, title, maybe like page count, something like that, if we want to have that on there.
Okay. So I put an ISBN, which is like the ID. I don't know what that stands for, like International Book Number, something like that. It's like the.
Yeah, something. Yeah, definitely.
So we want page count, and then a video. A video is going to have different properties.
Yeah, probably maybe title as a shared property, but beyond that, I think it's all gonna be quite different.
Video has a title and maybe I don't know, maybe like a skew or something like that is what we refer to the ID for the video. But we can keep this pretty simple.
Yeah, for sure.
Okay, cool. So in our store, we're going to have users. Users are going to place an order, and then they're going to add books and videos to their order. I think that's the basic functionality that we want to have there captured in our graph model. So the next step is we want to start the API application. We know we're going to use the Neo4j GraphQL library. I think there's a sort of a quick start here. Yeah, so basically what we're going to do is create a new node application, and then we're going to use Apollo server to create a GraphQL server. We'll use the Neo4j GraphQL library to take care of generating database fetching logic. We'll have to write some type definitions to basically tell the Neo4j GraphQL library what data we want to work with. So I'm going to do an npm init-y, which is going to create a new project for us, and then install a few things. So what do we need? We need the Neo4j GraphQL library.
Yes, so that's the library itself, but then there are a couple of peer dependencies there, one of which is the kind of core GraphQL library, and then also a Neo4j driver library as well. And let's just use the latest one.
Cool. And then we'll also need Apollo server.
Yeah, so this isn't a peer dependency, but this will be our server of choice for hosting our GraphQL schema that we build.
Cool. So while that's installing, let's create a new file. Oops. Index.js. And so here we're going to start off by importing some of our dependencies we're going to use. We'll start off with the GQL template tag and Apollo server. And what else? The Neo4j GraphQL class.
Yep.
And we'll need a Neo4j driver instance.
Absolutely.
And so the basic kind of structure here, and we can see this, I think, in the get started. Yeah, that looks pretty similar. Is
yes, yeah.
We're going to write our type definitions. And maybe let's just leave this as kind of a placeholder for now. So we know we have at least a user with a username. We'll come back and fill that in later.
Yep.
And the type definitions, that's what is going to define our data model, right? So this is the data that we're going to work with, and then we're going to pass that to the Neo4j GraphQL library, which is then going to, I guess, how do you think of that? Like generate a schema from the type definitions? I guess, is that a good way to think of that?
Yeah, so it generates a lot of things. It takes those type definitions and it will generate a schema massively larger than what you add in, and it includes all sorts of filters, mutations, mutation inputs and outputs, the works, and then also all of the resolvers for resolving each of those queries and mutations. And those resolvers are going to generate that cipher for you and execute it against the database. And yes, and then at the end of all of that, you essentially pull out a schema object which contains all of that good stuff.
Cool, right. So we don't have to think about like defining the query type and the mutation type and what we want the entry points for the API to be. That's all kind of taken care of for us, right?
That's all taken care of for you. You can, of course, always add extras and extra queries and mutations with custom behavior, but I don't think we'll be covering that today, and that's kind of a more advanced use case.
For sure. Cool. So the next step is to create our driver instance. So we're going to create a connection to our Neo4j Aura instance. Let's store these as environment variables.
Yeah, that sounds sensible.
So we'll have Neo4j URI, and then for our password, this is neo4j.auth.basic. We'll say Neo4j user. And Neo4j password. And then what I like to do is create a .env file and store our environment variables there. And then we would have this locally, and then we wouldn't check this in to like version control, something like that.
Yep.
So we know our username is Neo4j, and the password is something that I saved earlier, hopefully.
Yeah, let's hope you've remembered where you put that now.
There it is. And that's just what was generated for us by Aura when we created the instance. We can change that later. And then the other thing we need is the connection string for our Neo4j Aura instance, which we can see in the Aura console dashboard. That is right here. And then I like to use, this is a package called .env to read these .env files and set them in Node apps. Daryl, do you use this, or do you have other methods for dealing with environment variables?
Yep. Also a heavy user of this one. It's a really good piece of kit.
Cool. So we'll install that, and then to initialize it, I think something.
Yeah, I've gotten so used to initializing that with TypeScript now. I've almost forgotten how to do it in JavaScript.
Cool. So that will set our environment variables for our connection credentials to Aura. I guess, what's the next thing we need to do?
I'll quickly just add a little typo there, and then that should be good. But yeah, now let's move on to yes, let's make our kind of Neo4j GraphQL instance. Let's generate a schema. We might want to maybe finish our type definitions off first. Really up to you, whichever approach you want to take here.
Yeah, let's just create our Neo4j GraphQL instance and get Apollo server up and running. Make sure we can connect to Aura, and then go back and finish off our type defs.
Yeah, sounds like a plan.
So we have our driver. Let's do a Neo schema. Call it is going to be a instance of Neo4j GraphQL, and we'll pass our type defs and our driver instance.
Yes, you've got a couple of options with the driver. You can either pass it in on construction like we're doing here, or you can also pass it in per request in the context of the requests. So there's a couple of different routes you can take, but this is definitely the simpler of the two.
Cool. And then we'll create a new Apollo server instance. And Apollo server, so you can use Apollo server in a few different ways as well. Oftentimes, if you're writing resolvers by hand, you're passing typedefs and resolvers, and then Apollo server will combine those two into an executable GraphQL schema and serve that. In this case, though, our Neo4j GraphQL instance is going to create the executable schema object for us, so we'll just pass that to Apollo server.
Yeah.
So we call the .schema on our Neo schema object. What are the other things? Are there other methods on this Neo4j GraphQL instance that we could use?
Yeah, we've got a few things in there. I think one of the most useful is there's a method which is to check for Neo4j compatibility. Mm-hmm. So it will check whether the database is at the required minimum version or above, and it will check whether all of the functions and procedures the library needs are available on the library as well. It could just be a nice kind of quick kind of check when you're starting up an application, just to make sure your database is up to scratch.
Gotcha. We've got a question in the chat here from Tim, who says, could I use GraphQL schema with AWS Amplify and Appsync?
Funny, we were just discussing this yesterday, weren't we? And it's not actually something we've tried yet, but it should 100% be possible. Everything that we output from the Neo4j GraphQL library is just pure GraphQL objects, pure kind of GraphQL schema and type definitions and resolvers. So there's no reason why you shouldn't be able to use it with that stack. But it is definitely something I want to investigate myself and have a play around with, because it's obviously a very popular stack for deploying your GraphQL schemas at the moment. And yeah, it would just be nice to play with that, really.
Yeah, and what would that look like as a starting point? Maybe I know Appsync has Lambda resolvers. Would it be maybe looking at how to query Neo4j in one of the Lambda resolvers, or what would be kind of a starting point for investigating that?
Yeah, this is something I was literally reading up on this last night, and yeah, it's obviously you've got the Lambda resolvers with Appsync, but then there's also is it like mapped resolvers which use the velocity templating engine, right? I think there's a couple of different ways in which you can map resolvers using Appsync. However, to me, the Lambda method feels more logical, and it also feels more sensible, and kind of, I think serverless is definitely the way forward with this kind of thing. So yeah, it'd be looking at possibly a way of kind of extracting the resolvers out of a schema, which I'm pretty sure you can do. And if that's not possible, then we'd definitely be keen to kind of look into that ourselves at some point, because yeah, we definitely want to be able to cater for this use case.
For sure, yeah. Yeah, good question. Thanks, Tim.
Yeah, thanks.
Okay, cool. So we've got our Apollo server instance. We've got our Neo4j GraphQL schema object. I guess the next thing is just start up our server.
Yeah, for sure.
So we'll call server.listen, which will then give us a callback with the URL of where our server is listening. So we'll just log that. Something like that.
Yeah, that's pretty much it, really. Not a huge amount of boilerplate to get a minimal application up and running. So yeah.
Yeah, so that's what, 25 lines? Although I guess we do need to still flesh out our type defs.
We do, yes.
But let's give this script a run and see if it works. The other thing I'm going to do before we start this is set the debug environment variable. And this will, if we look at in the troubleshooting section of the docs, this is going to log a bunch of things. This is helpful for development. The thing I like to look at here mostly is the generated cipher queries, just to kind of make sure that that's what I would expect, I guess, from my schema. I don't know. I like to see lots of things sliding by as I'm developing, so it's helpful for that.
Yeah, you can admire beautiful generated cipher.
Cool. So it says running on localhost 4000, and we get redirected to Apollo Studio. So it's worth pointing out that we're now using, I think, the 3.0 version. Let's check our package JSON of Apollo server. Yeah, 3.1.2 is already out. And in previous versions of Apollo server, by default, you saw GraphQL Playground running, which is kind of like a query workbench for GraphQL. Now in the 3.0 version of Apollo server, they've switched to redirecting to Studio, which is sort of like a new and improved version of Playground. GraphQL Playground had been deprecated for a while, so it's good to see some evolution here with Apollo Studio. So anyway, that's why it may look a little bit different.
Yeah.
So I guess, let's see, we can take a look at, because we just have these super simple type defs here, we have a pretty simple schema. So if we look here at the root, we can see we have queries and mutations. Let me make this a little bigger. Hopefully that's legible. So the query field, these are like the entry points for our API. We have two. We have users, or users count. Let's start with user. So if we run this, we can see, first of all, over on the right, the generated cipher. So we're matching on users, and in our selection set, we just had username. So just return the username property of any nodes that we match on. Of course, we don't have any data in our database, but that's fine. This is just kind of testing that, yep, this is talking to our Aura instance. So the basic skeleton is there.
Yeah, and already you just saw back there one of the new features of the 2.0 release being the root level count queries. So you saw various users, but then also users count. That's a new addition in this version of the library, and it will essentially just give you the number of users in a database, but you can also apply filters to that as well. So it's very useful for when you're doing pagination if you want to calculate the total number of pages which are available to users.
Oh, gotcha. So we can use the same filters here that we're using on a query that we want to paginate as well.
Absolutely. Yep.
Gotcha. Super useful. Cool. Well, I think the next step is now to take the rest of our graph model and define our GraphQL type definitions to describe this property graph. Do you want to take us from there, Daryl?
Yeah, why not? Let me get that up. Tell me, is it possible to format this document, by the way? Oh no, it's not. Never mind.
We can do the Command Shift P.
Hey, there we go. I think live share lets you do it and not me. Great. So we've already got our user there with the single username property that we have in our arrows diagram. So first of all, let's just add in all of our other types, I think, and then we can kind of connect them all together once we've got all of that in. So an order ID is a string, and then we've also got created, which is a date time. Date times are natively supported in the Neo4j GraphQL library, so no need for custom scalars as you may have used before with GraphQL for temporal types. And then finally, we have a video, which has a title and also an SKU. And then we have type book, which has a title, ISBN, and there's a page count from there as well. So that's our basic 4 types with all of the kind of primitive fields that each of those have, but it's not very graphy at this stage. This is essentially just these 4 nodes with no connections between them. So let's add all of them in. So what we do when we want to do this is we say a user, so if the user has orders, we want to say that's going to be of order type. For arrays, I always like to mark them kind of with the double non-nulls here. Essentially, it always says that orders can never be null. It's always an empty array, which kind of makes much more sense with arrays, I think. And then also, every single item within that array has to be non-null. So it has to be an order or nothing. You can't have null values in there. So I think that makes a lot more sense for arrays. And then we dive into our first directive. So the relationship directive is provided with the Neo4j GraphQL library, and it's what we use under the hood to kind of connect all of these types together. And much like in Neo4j, a relationship has a type. So we've said placed for this. And then we also give it a direction. So for this one, it's users have placed an order. So the direction for this is out. And then you could either leave it like that, or you can kind of map it back the other way as well. So if we kind of say an order has one user, what should we call that word? Like just user or a creator, or I'm trying to think of a sensible field name for that.
Maybe customer.
Customer, that's exactly the kind of word I was looking for. So yes, an order has a customer. And being a bit lazy, I will just copy that one further and change that direction to in. So you've always got the matching in and out on those ones. One thing I've noticed here is that we've got an order could have either a video or books. So we could represent that directly, but this relationship type here is the same. An order contains videos or it contains books. That to me kind of screams unions, and we've done quite a lot of work on unions in this 2.0 release. So I think it would be great to have a play around with them, if you agree, Will.
For sure, yeah.
Great. So union, we'll maybe call it product.
Mm-hmm.
And that union can be either a video or a book. Nice and simple. And what that allows us to do is up here, we can just do products. Once again, with the non-nulls. Contains direction. And there we go. I mean, we could also add kind of those backlinks into both the video and book types, but would you agree maybe we should maybe leave it without that in this instance?
Yeah, so that would be if we were querying a particular video, we could then look at all of the orders that contained that video. I don't think we need that necessarily. Again,
we can always add it back in later if we decide we want it later, right?
Exactly. Yeah. There is one thing I'm curious about here before we start querying some data. So I see here that order ID is like a unique ID, and created is like a timestamp of when that order node was created. Is there a way that we could have values for those fields be auto-generated for us when we create the orders? Could we generate a random UUID and save that, and similar for a timestamp field for created?
Yeah, for sure. That's a great spot. Let's do that. So yeah, as you've already noted, this is actually an ID, and of course there is an ID type in GraphQL, which always serializes to a string anyway. So let's use that ID type. And let's also say it's going to be non-null, right? Because it's going to be very hard to find our data if it doesn't have an ID. And then we have this really simple directive here, which is literally just ID, which will, if adding that alone, will auto-generate that ID for you when you create an order. And it will also prevent you from changing that ID as well. It will essentially, it's kind of like you're basically saying this is like a managed ID now. We're managing this ID, and users should have no need to change it from that point. And yeah, also as you pointed out, created as it is a created timestamp, not an updated timestamp. I think once again it makes sense to make this non-null because an order is always created. It doesn't just kind of appear out of nowhere. So I think we can always safely say that date time is going to be set. And then for this one, there's a different directive, which is timestamp. And for this one, you provide arguments. So this is all in the documentation. There is actually a directives index in that documentation, about 3/4 of the way down. And in there, you've got a list of all of the different directives that are supported by the Neo4j GraphQL library. And in that page, you can go to timestamp and find the documentation for that. And then, yeah, that refers through to where it belongs. And as you can see, you've got the actual definition there and some example use cases. And the one that we're after is that user created app. You can see it's operations, and then in a bracket, you've got create as the operation enum, and that's that.
So that means that the created field will be set when that ordered node is created by a mutation. If we didn't add that operations argument to the timestamp directive, then that value would be updated anytime that we update the node. Is that right?
Yeah, that's correct. So yeah, the default, as you can see in that definition there, is the brackets create and update. So it will essentially just be a modified timestamp at that point, pretty much.
Cool, great. Yeah, this makes a lot of sense, I guess, because the client of our application isn't going to want to be thinking about generating order IDs or fetching the client timestamp when the order is created. So this makes a lot of sense that we can generate those on the server side.
Yeah, absolutely.
So we've got another question in the chat. It says, this library is only for JavaScript. How about Rustlang? Yeah, that's a good question. Actually, Gerald, do you know what the state in general of GraphQL tooling in Rust is? I haven't really done much in Rust.
I honestly have no idea. I'm afraid it's not something I've looked into. Very cool language and something I'd like to look into, but yeah, not something I've got around to yet.
So I'm sure there is a GraphQL server implementation in Rust. I guess what you're rendering specifically, is there a sort of Neo4j GraphQL library equivalent in Rust? And the answer is no. This official Neo4j GraphQL library is TypeScript and JavaScript only. There are lots of different ways, though, to build GraphQL APIs, right? So you can certainly leverage some of the other tooling for interacting with Neo4j as you're building GraphQL APIs. But yeah, to take advantage of a lot of the auto-generated schema and query functionality, unfortunately, this is only available in the official Neo4j GraphQL library.
Yeah.
Cool. So should we restart our server?
Absolutely. Yeah. Sounds like a plan.
So we'll restart that. And now if we take a look at Studio, if we slide over the documentation and look at query.
Did we save that file? I know that live share can be a bit funky with saving of files.
Ah, I see.
Yeah, I tried to save it, and yeah, it doesn't make it through the other end.
Oh yeah, no, let's give it a format too. I know that was bothering you.
Just a little bit, yeah.
Yeah, I don't have format on autosave set up. I should do that. Okay, cool. But you saw it. Now, once we saved that file and restarted our server, we had a bunch of new query fields that showed up in Apollo Studio. So now, instead of just users, now we have users, orders, videos, books, and the associated count fields with those. And if we look at the mutation, we also now have mutation operations for all of these types as well. So create users, delete users, update users, same for orders, videos, books, and so on. So I guess now it's time to create some data. Let's add some data through mutations.
Yeah, let's do it.
Okay, so let's write a mutation. What should we create first? Maybe some users?
Yeah, let's do that.
So one thing I've noticed about Apollo Studio is that it wants to create GraphQL variables for me. But one thing I've noticed is I then kind of lose the really nice autocomplete for my input objects if they're variables in Apollo Studio, but you can toggle back to inline variables, and then I have autocomplete. So
I hadn't found that option yet, so I'll keep that in mind in future. Yeah, I think definitely more opinionated than GraphQL Playground. I feel like with the variables, it would be very useful if you're building queries queries and mutations that you want to pull out into your client applications, because of course then that's a much more dynamic place. So you're probably going to be using variables instead of inline variables. So I think they've very much kind of taken the opinionation stance of building queries and mutations for Apollo client.
yeah, that makes sense. I wonder if you can, if you build them inline. Oh yeah, so if you build them inline, you can then extract them into variables, which would be, that would be nice.
Cool.
Yeah, sweet.
Yeah, that's pretty awesome actually.
Okay, so let's see. This can be an array of input objects, right?
Yeah, it can. Yep.
So our user object is pretty simple. It just has a username. Let's just go with one for Daryl and one for me, maybe.
Yeah, that sounds good.
And then our selection set will be just the users that we've created.
Yep.
So we can format that, make sure we got that right. Okay, cool. So it says we have two users. Let's jump over to Neo4j browser, maybe, just to make sure we're seeing what we expect in the database.
Yeah, it's always good to check for sure.
Gotta find that password again. There it goes. Username Neo4j. And my password. No, don't want to save it. Okay, and so we should see two user nodes. Let's zoom in here. One for me and one for Daryl with just a username property.
Yep.
Cool. So that's what we kind of expect here. What else? Let's create some products.
Yeah, I think let's create kind of each kind of branch of our graph, and then we can put some orders in the middle when we've got everything we need in.
So we'll create some books. Let's go back to inline variables. There we go. And so books have a title. Let's, how about the graph algorithms book? We'll add that. I also have an ISBN. I'm not sure what the ISBN is. We'll just put in something fake there. And then,
yeah, I think we also had a page count as well, but now maybe regretting putting that field in, as it's more to populate, isn't it?
right, page count. Here, I have a copy of that book. We can check to make sure exactly.
Some actual accurate test data for the first time ever.
We can we just put in my bookcase in that. 237 pages. This is the Graph Algorithms book.
Nice.
Which you can download for free. I will dig up the link too. Okay, so title, we made up some ISBN, the page count. Let's run that. And let's add some other books. How about the Graph Databases book? Again, we'll just create some random ISBN. Page count will be wrong. That's okay. And how about one more book about full stack GraphQL? That's another good one.
Slightly opinionated on that one.
Okay, so that's books. Maybe some videos next.
Yeah, for sure. I like how we call them videos as well. I feel like I've gone back to the 90s with like kind of Blockbuster and all of that good stuff.
Exactly. For me, it was Hastings, which was the combination bookstore and video store where I grew up.
Oh, yeah, I was about to say that definitely sounds like an Americanism. I don't think I've come across that one before.
I think it's since definitely gone out of business. They had video games too.
Yeah.
Okay, we need a title for our first video.
Yeah, should we just go movie? Should we do like Pulp Fiction or something?
Let's, yeah, Pulp Fiction, that works.
I mean, it's not The Matrix, right? So I feel like that's a step in the right direction.
Yeah, and some random skew. And then for our selection set, videos title. What's another? Let's add one more video.
Isn't it amazing how blank the brain goes? Let's go with like Alien. Nice, short to type, right?
That is, I like that. Very nice.
It's worth noting as well that these don't have to be created one by one like we're doing here. This could all be done in like a giant array. That input object can be an array. You could create multiples in this root level mutation.
Right, exactly. Which we did for users, right?
Exactly. Yes. Yeah. Just worth our reminding, I guess.
Cool. So now we've got videos, we've got users, we've got books in the database. Now we're ready to order some products. Our store is open for business.
Yeah, let's do it.
So this is going to be what, create orders mutation?
Yeah, let's go with that. I think that's the most logical route to take here, but there's various ways that you can do this, including starting at the user, and you can basically update that user and create an order as a nested operation there. So basically, wherever there's a connection, you can traverse that connection and perform mutations over it. So it's pretty powerful and very flexible as well.
Cool. So starting off here, so our order, I guess because we're auto-generating the ID and the created timestamp, which we don't need to add in the input, in the mutation input. So we just need to find the customer that we're creating this order for,
Yeah.
and then the products.
Yep.
So for the customer, in this sort of nested mutation operation here, we have a connect and a create option. So what are the difference between those two here?
Yeah, so connect is going to be where you've got an existing customer, like we have in this situation. Both me and Will are already existing customers, so we want to connect to either of them, and essentially that's going to take a where clause. So that's essentially connect where username is Daryl. Create is going to be creating a brand new connected node using a create input object. So two different operations there.
So that would be if we wanted to create a new user at the same time that we're creating the order, which we don't want to do in this case.
Exactly. Yeah, I feel like that would be more appropriate for if you were starting at the user end, you would update that user and create an order under it. It is the kind of situation where you might use that.
So I'm going to say where username is Daryl. And notice here that I had a node option in the input object as well. This is new in the 2.0 release, is it?
It is, yeah. It's to abstract out those relationship properties from node properties, so it will allow you to filter on either of them separately.
Gotcha. So in previous versions, we would just say where username is Daryl instead of having this this node object that we add here. So I guess that's maybe one change to be aware of as you're switching to the 2.0 version.
That's correct. Yeah.
Okay, so let's go ahead and add our selection set. So we get rid of this red squiggle here. So our order is going to have a generated order ID and the time it's created. And then it's also going to have products. And here we're going to have to use an inline fragment, right? So because
that's correct, yeah.
Because product is a union. If we look over here at our type defs, we said products is an array object field of the product union type, which can either be video or book. So we use an inline fragment to say, when this is a book, give me the title, ISBN, and page count. And when this is a video, we have different fields. Give me, what did it say, title and skew. Cool, let's format that so it's a little more readable. Okay, so we've got our customer, but now we want to add some products to this order.
Yep.
And this is going to be similar. We have the option here. I guess we could choose if this is a book or a video, because again, products is the union. So this is kind of from the other side, the mutation input object. So I guess, Daryl, what do you want to order here, a book or a video?
I'm a big movie fan myself, so let's go for a video. It is worth noting that this is one of the more kind of discrete improvements we've made in this release. Previously, that would have been, input, and it would have been products underscore video, and it was a bit unwieldy and it was inconsistent. So what we've now done is we've lifted that kind of suffix after the underscore down a level, and it's now kind of much more object-based and much more expressive. So we think it's much nicer to use now.
Yeah, makes sense. Cool. And similar, we're going to connect to existing where the node title is, which one here?
Let's go. Alien is nice and short to type.
Alien, got it. Give this a format, and then should we leave it at that? Should we add a book to this as well, maybe?
Yeah, you can do. Why not? If you can find which curly brace it comes after. Yeah, there we go.
So here we're going to connect where the node title is. What book do you want to order?
Shall we go for graph algorithms?
Graph algorithms. Excellent choice. Highly recommend it.
Thank you kindly.
Okay, let's format that. Okay, so you can see kind of the nested operations in the mutation here. So we're going to create an order, and that should create the order node, generate the order ID and created timestamp, and then create relationships to the alien video and the graph algorithms book.
Yeah, it sounds good to me.
And you can see what we get back here. So here's our generated order ID and the timestamp and the products this order contained. And if we go over to Neo4j browser, you can now see that Daryl placed this order, and it contains one video and one book.
Yep, and you can see there that annotation there is our generated ID, that order ID, which was generated by that ID directive.
Cool. So
yeah, you're going to place an order for yourself?
yeah,
Why not?
let's order full stack GraphQL. What was the other video we added? Pulp Fiction?
Oh yeah, Pulp Fiction, yeah.
Let's run that. And then I'm going to create a few orders here because I want to take a look at our pagination options.
Yes.
So let's order graph algorithms. And we'll just the book.
Maybe you're going to order a few copies for your friends, perhaps.
Okay, cool. So that's like 3 or 4 orders. Now, if we
that'll do.
Check that out. Yep, cool. We've got 3 orders, some books, some videos. Great. So, what should we look at next? Should we take a look at how we could start from maybe like searching for all the orders and then the different options for paginating those?
Yeah, we could take a look at that, or we could, take a look at some ways that we could improve this model as well, ideally using relationship properties, whatever you feel is best.
Cool. Yeah, let's start with pagination.
Yeah.
So let's say that I have some, I don't know, like table view in my application. Maybe this is like the admin view, and I'm looking at all the orders, and I want to like sort by, I don't know, like date they were placed or something. And I'm a very successful online store. I've got millions of orders. I don't want to bring all those in one query. I want to paginate through those in a table view in the application.
Yeah.
So that, to start off, we might query all of the orders, the order ID, the date it was created, and then the products. And again, we need to use an inline fragment here. Title, ISBN, and when it's a video, title and SKU. Okay, so I can run this, and there's only a handful of orders here, and that comes back. But imagine that we had just millions of orders, and we needed to paginate these. So we have a couple of options for pagination.
Yeah, so it's worth I'll walk you through these because different options are available in different places. So at the moment, at the root where we are now, if we're querying for orders, you have like page-based pagination as an option. So you can say, I want the first 5 or first maybe 1 or 2 in this example, first 2 entries after a certain offset is what you have available at the root. And then on relationship fields, you have both that option as well as additional new cursor-based pagination options as well.
Cool.
So I would imagine maybe in this application, we could demonstrate a bit of both because, we could have like pages on our table, but then maybe you can drop down an order and you can kind of view a products underneath it. And maybe that's more of like a, load as you scroll kind of idea or something like that. Or maybe there's like a load more kind of button, for example.
Yeah. So let's look at those 2 options. So the first one you said was kind of page-based, where I'm saying, give me, I don't know, like maybe I'm just looking at one at a time. So initially that's going to be like limit 1, offset 0, and then in this case I probably want to sort by created in descending order.
Yeah, let's go for that.
And so
that's another change from the 1.0 release. There is, see that just very discrete rename of skip to offset. and that's to marry up to Apollo Client 3, which has become a bit more opinionated about pagination options now and prefers offset to skip. So we've decided to take the opportunity to align there.
Got it. That makes sense. And so this is where I would use the orders count query to get the total number of orders, and it would tell me like 5 or something like that in this case. And so because I'm bringing back just one at a time, I know I'm going to have 5 pages to go through. So when I click next in the application, still going to be like limit 1, but now offset 1, and I'll get the next one to load in the table. So that's, what do you call this, page-based? Is offset-based pagination?
Yeah, offset-based, page-based, I think. Offset-based is the correct word, and then you might use that to do page-based pagination in your application.
And so the other type is cursor-based pagination, which you said is available on relationship field. So maybe if I was looking at starting from the users and then looking at the orders per user, that's where I would be able to use cursor-based pagination?
Yeah, so already something that won't quite work there is that you're trying to query a bit about orders field. This cursor-based pagination isn't actually available on that field because cursor-based pagination in GraphQL is implemented by the relay spec, which is the GraphQL connection cursors specification. So essentially, you need to have a connection object in order to do this. So as well as orders, there's also now a orders connection field, which will, as well as returning kind of the edges, which will take you to the orders, there's also like this page info object, which basically tells you, is there a next page? What's the last cursor of this particular page? And also we've also added in like a total count field as well, which means you can kind of implement page-based pagination with this as well. So it's pretty versatile.
Gotcha. So we have our option here. So we don't need orders. So we'll remove that from the selection set. So for the user, let's have the username, and then we want to see the edges. So we'll get cursor and then the node.
Yeah, so the cursor is available on the edges, but with Relay Modern, it's not actually required to fetch that cursor. We've left it in as an option, but actually you can get the important cursor, which is the last one in the list, from that page info object. So that's generally going to be the recommended way to do this.
Got it. So let's grab page info. And so here we have the end cursor, has next page, has previous page. So I guess those are Booleans that are going to tell us if we can paginate forward and backward from the current page, right?
Precisely, yeah.
Gotcha. So end cursor and start. What's the difference between the end cursor and start cursor?
So really, end cursor is the one that's important here because with Relay, you can expose a few different pagination options. We've gone with first and after, which are essentially kind of forward pagination. You can also implement first and before. No, the first and after, before and there's another one. My brain's now mush thinking about all of this. Quite complex. So essentially, end cursor and has next page are really the arguments that are useful for us whilst doing this pagination.
Got it. So then in this case, the node, this is going to be our order object, right?
It is, yes.
So the date was created, the order ID, and then we should have the products in the order, which again, we will need to use inline fragment.
Yeah.
Since that is a union.
Yeah, as you can tell, it is a bit more verbose, but it's not just for cursor-based pagination that this connection object is here, and we'll go into its extra uses later down the line as well.
Cool. So now, okay, so I see for Daryl, here's the orders connection, the page info, and
Yeah, so I think if I remember correctly, I just had one order, right? So I'm literally just start and end cursor are exactly the same, and I have neither a next or a previous page.
gotcha.
But then I believe you posted, you had 3 or 4 orders, right?
I do. And again, I also don't have a next page because we didn't put in a limit here, right? We're just saying,
Exactly. We've
give me
not,
all of
at the
them.
moment, we're just kind of getting the entire connection. So there's no filter there, there's no pagination argument. So we're definitely going to be wanting to add in some of them.
So let's sort these by created in descending.
Once again, you're seeing that node object there. It's going to become a lot more familiar. And once again, that's to facilitate sorting also on relationship properties.
And then here we'll say just bring back the first 2 order connections. Okay, and so now I do have a next page since we're just bringing back 2 orders ordered by created date. So I would grab the end cursor.
That's the one. Yep.
To get the next page. And now I'm going to say, give me the page after. And we'll switch to inline variables.
Constantly trying to make you use variables.
After, and this is just a string?
That's just that string. Yeah, that's correct.
So now this is saying, give me the next 2 order connections after this cursor.
Yeah, so it's worth noting that, that cursor is obviously really only going to work for your orders. So ideally, you've probably also got a filter on the user's query, which is basically, query users where username is Will, and then you're paginating through your own connections, if that makes sense, or so your own orders.
Right here, so here we're just looking at all users, but in our application,
exactly.
we've probably clicked through the detail for a certain user.
Yeah.
Cool. Okay, and now we see that has next page is false because now we're at the end of the orders for this user.
Yep, looks good.
Cool. Yeah. So really, what we want here is we want some where filter where username is Will. So something like that. That's what we should have started with.
Yeah, I think that's a more sensible query and much more in line with maybe what our application might look like.
Right, makes sense. Cool. So there's one thing that is kind of missing in our model here, and that is, what if we want to order multiple copies of a book, right? What if I'm ordering, I don't know, like Christmas presents, and I want to order multiple copies of a book? How would I represent that in this model? And there isn't really a great way. I mean, we could create additional relationships, I guess, but that's perhaps a bit confusing. This is where properties on relationships come in. So we can add, let's add maybe like a quantity.
Yep, that sounds good.
Relationship property here. We can add that to both the contains relationship for video and book. So now we want to be able to say, okay, I'm going to add this book to the order, and I'm going to order like 10 copies of it. So I want quantity to be 10, modeled as a relationship property.
Yep.
And it makes sense to model this as a relationship property in this case because we're talking about a property that the value is relevant to both the order and the book, right? It doesn't really make sense to store that on the book because it's not specific to the graph algorithms book. It's only specific to the graph algorithms book in the context of the order, right? So anytime we have something that applies to both nodes, it makes sense to add that as a relationship property.
Yeah, I feel like kind of price is almost a good example of this as well, because a price isn't fixed, right? The price of a book might change, it might be on special offer, so it's important to kind of lock in the price that the customer paid at the time in their order.
Yep, makes sense. You can have like discounts or prices can change. That makes sense.
Yeah, exactly.
Cool. So we want to update our GraphQL type definitions now to take into account this quantity relationship property. And Gerald, you said this idea of relationship properties, this is a new feature in specifically the 2.0 release.
Yeah, this was initially really what we set out to do. This was, version 2 was for relationship properties and purely relationship properties, so that we can essentially model the the full Neo4j data model in the GraphQL library. And then, yeah, we decided to add in a few extra features as well. But this is really what we set out to achieve, and it definitely had the most focus.
Cool. So I dropped a link to the relationship properties of the documentation into the chat if you want to take a look at that in the documentation. I see we have another question from Tim in the chat. He's asking if the Neo4j GraphQL library supports subscriptions for subscribing to event-driven data.
No, we don't natively kind of support subscriptions based on mutations performed through the GraphQL library or kind of performed directly in a database. You can kind of add your own subscription. You can kind of pass in your own subscriptions and their resolvers, but that's the extent of subscription support at this time.
So there's nothing to prevent you from implementing your own subscriptions, but you don't really get anything out of the box for it currently.
Precisely, yeah.
Gotcha. Cool. Well, let's update our type defs here to take this quantity field into account. Do you want to add that, Daryl?
Yeah, for sure. So as you can see in the documentation there, this is modeled as an interface. So the kind of convention I like to use is obviously interface, and then I think we've got this relationship is called contains, right? So I like to take the approach of calling that interface contains, and then a quantity, which is an int. You might ask kind of why we've taken this interface approach. It conceptually makes sense because essentially what we're going to do, despite in this example it's only going to be single directional. So essentially what we're going to do is here at this products field, we're going to have relationship type contains direction out. Then we're going to add a properties key in here and basically point to that new interface. And it's as simple as that. We think this is an improvement over the old Neo4j Labs library, which was kind of a bit more complex to add in relationship properties. We wanted it to feel more of an extension of your existing type definitions rather than a complete rewrite. And that interface makes sense because
Oh, I think we lost Daryl there. Let's finish off here. Let me just make sure didn't drop the stream. No, I think we're good. So Daryl, I can hear you. I can hear your audio, but we lost your video. Let me. I think. So I can hear you. Let me tweak this. We'll see if we can get the video back. There we go. Okay, I can
Back in
see you
business?
and hear you. Yeah. Cool. So you were just
Cool.
adding the contains interface, which represents the relationship properties for the uh, order contains product relationship.
Yes, that's correct. Yeah.
Cool. So that is the contains interface, and then we add that to the properties argument on the relationship directive. And I think that's the only change we need to make in the type defs. Is that right?
Simple as that. Yeah.
Cool. So we'll save that and restart our GraphQL server. And now we jump over to Apollo Studio. Let's create a new order and let's order 10 copies of the Graph Algorithms book. And let's
Yep.
see how we do that in the mutation. So it's going to be create orders. And again, I'm going to switch back to inline variables. Okay, so our input first is the customer. So we're going to connect to an existing customer where node, what do we say, username
Yep.
is Will. And let's go ahead and add our selection set here. So we get rid of our red squiggles. So our order is going to have what, a created, and it's going to also have an order ID. And now we have the products and the products connection. So earlier, Daryl, you were telling us about the products connection and the different ways that we can use that connection type. So I'm guessing because we're going to want to model quantity as a relationship property, we're now going to be looking at the products connection instead of just the products field. Is that right?
Yeah, that's correct. We left the kind of, we won't call it legacy, but maybe like direct products field. It essentially just jumps straight over to the neighboring node. Just for brevity, really, because if you're nesting, several layers deep, and it's always the connection field, it's going to get incredibly verbose very, very quick. So sometimes you just do want to just hop straight over if there's no relationship properties involved. But whenever you've got relationship properties, yeah, definitely using that products connection field. And the edges maps to the relationship, and then the node obviously maps to the node. And this is relay terminology with the edges, node, cursor, all of that stuff.
Cool. So I see here now in edges, I have quantity. So that is our relationship property. And then I also have node, which in this case is going to be our product. So it's going to be a book or a video, which means we need the inline fragment, right?
That's correct, yeah.
Let's just do book because we're only going to order book in this. We don't have videos.
Yeah, sounds good.
Okay, so let's format this. So we have the customer.
Yeah, let's find where the...
I think that's the curly brace that ends customer. So now we need products.
Yep, sounds good.
And we said we're going to order book. We're going to connect to an existing book.
Yeah, so this is where the changes come in now. So we have that where, which we're going to use to match up to the book that we want to purchase, but then also this edge property. And this is where we set our relationship properties. We decided to kind of make edge the common terminology whilst using the GraphQL side of things, so that we don't have this mixed economy of relationship and edge everywhere.
Right, since edge comes from the sort of relay terminology, right?
Yeah, exactly. So the only place you're really going to see relationship is whilst you're defining your type definitions, because we think at that stage of development, you're more thinking about your graph and your graph data model. but at this stage, you're really kind of deep into GraphQL land and relay land. So so kind of fixing on that edge terminology, which is common in relay, we feel makes sense at this stage.
Gotcha, makes sense. Okay, so let's add in our relationship property value now. So if I say edge, I have quantity, and we're going to order 10 of these.
Yeah, this is real curly brace hell, isn't it?
So there we go. Now we want the where, and we're going to find the book node where the title is graph algorithms. And we have a curly brace problem somewhere.
Oh, of course we do.
What do we do here? So customer, we got products. Do we just have an extra curly brace maybe? No. Let's see.
Do we not have enough curly braces?
Let's see. So I deleted one. Were we missing one here? I don't think so. No. Let's see. So products has book, connect, edge, quantity.
Yeah, you'll want. So you won't. Never mind. Node.
Connect the edge where the node title is graph algorithms. That's the edge. That's connect. That's the product. That's the input. Oh, maybe it's not curly braces. So just a space.
No. Also, I'm leaning on the screen now, and now I've gone completely out of focus, which is always good.
It didn't like the space there.
There we go. Yeah,
it
back.
Didn't like the space before book for some reason. Not sure.
Well, I guess it's still fairly soon after the release of Apollo Studio. I guess maybe a few little bugs left over, perhaps.
Okay, so let's run that. And so we have created an order that should have 10 sort as the quantity for the book. So when we see that in the GraphQL result, but let's just jump over to the database. So let's start here, user will. So placed some orders. And here's the most recent order that I placed for graph algorithms book. And we can see we have quantity 10 stored as relationship property on this contains relationship. So now we're able to model and query relationship properties in Neo4j through GraphQL, which I think is a pretty cool improvement.
Yeah.
Cool. That is pretty neat.
Yeah, intrigued about that other edges entry, but maybe not one for looking into right now.
Yeah, so we covered some of the new features in the 2.0 release. Again, I'll drop another link to Daryl's blog post in the chat here. We covered most of these new features. We covered relationship properties. We covered cursor-based pagination. We took a look at the count queries. We looked at how union inputs are now handled in relationship fields as well. So I think we did a pretty good job of covering what's new in the 2.0 release.
Yeah, pretty sure we covered almost everything.
Cool, great. Well, I will push this code up to GitHub and share that in the recording description on YouTube, so you can find that to play along with as well. And the documentation is live now. If you want to check out this new 2.0 release, I see in the chat some folks are upvoting Tim's question on subscription, saying, yeah, this would be a useful feature. So yeah, I'm sure that is something to look into for the future.
Yeah, if you're not already kind of familiar with our GitHub repo, please do come and get engaged on there. We always love to hear kind of feature requests and love to know what's popular, and yeah, really keen to get your input. So thanks for that. We'll keep the subscriptions in mind.
Yeah, is the GitHub issues, is that sort of the best way to track those sort of feature requests?
Yeah, so in here, if you go new issue, you'll be taken through to like a template. You could either choose bug report or feature request. And yeah, please, if you see like a feature request in the issues already, please upvote it, comment on it, make your voice heard, and that really kind of guides the direction we take with this library.
Cool. I dropped a link to that in the chat, so yeah, definitely chime in with what you'd like to see. Cool. Well, anything else we should cover? I know we've been going for about a while now, but anything else you want to add, Daryl?
No, I don't think so. I think it's dinner time in the UK right now, so I'm keen for some food.
All right, great. Well, thanks to Daryl for joining us, and thanks for everyone for watching. And we will see you again in the next live stream. Cheers.
Cheers. Bye.